Okay, example problem number 3. An elevator has a mass of 100 kilograms and is accelerated upwards by a cable from rest at 1.33 meters per second. Situation is sketched. The object of interest is the elevator, which I've identified here. We are going to then draw a force and motion diagram. So I'm going to draw my motion diagram first. If it's starting from rest and going up, you have V1. V2, it's getting faster. V3 is getting faster still. Alright, and we have our change in velocity, which would be going up. To identify the objects of interest, we have the cable, and we have the Earth. Alright, now to draw my force diagram here. If we have the elevator here, we would then have the cable pulling up on this, and since the acceleration or the change in velocity arrow is pointing up, we have the cable on the elevator, and then this would be larger than the Earth pulling down on the elevator. Okay, so if we look at this, we only have forces in the vertical direction, so to write Newton's second law in component form, all we have to worry about is the y direction. So we have the sum of the forces in the y direction divided by the mass. We know what the acceleration is, and they're asking us to determine the force of the cable. So the acceleration in the y direction, written out in variable form, will be the force of the cable on the elevator minus the force of the Earth on the elevator divided by the mass of the elevator itself. So we know, since now we have directions here, I'm going to call up positive, I'm going to call down negative. So the Earth is pulling down, so this is a negative value here. The acceleration will be pointing up because the change in velocity is pointing up, so this is going to be a positive 1.3 meters per second. This will equal the force of the cable on the elevator minus the force of the Earth on the elevator, which to calculate is the mass of the elevator times our 10 newtons per kilogram, divided then by the 100 kilograms of the elevator itself. Okay, to solve for the force of the cable, what we're going to do here is multiply both sides by 100. Alright. This 100 will divide out with that. And 1.3 times 100 is going to be 130 newtons. This will equal the force of the cable on the elevator minus 100 kilograms times 10 newtons per kilogram, which this would then equal 1,000 newtons. Alright, we then add 1,000 to both sides, and we find out that the force of the cable on the elevator would equal 1,130 newtons. That is my final answer. I'll box it, and we are done with this problem.